Hi Trigoner, this is the second day of Notes 1.5 and we're going to start with a little warm-up. Let's see if you remembered what we learned about the discriminant in the first part of Notes 1.5. So go ahead and pause the video and see if you can choose which graph A, B, and C might possibly describe a function that has a discriminant that is given for 1, 2, 3, and 4. So go ahead and give it a try. Pause the video and see if you can do some matching. Go ahead and check your answers and see how you did. So for example, for number 1, notice if the discriminant is 20, you might, and here's what I'll put number 1 up here, you might end up with something, I'm just making this up right now, let's say you had, I don't know, like 2 plus or minus the square root of 20 all over 4, I just made that up. Notice that the square root of 20, so you would actually have 2 answers because you'd have 2 plus the root 20 over 4 and 2 minus root 20 over 4. So that's why we're expecting something like C, where you have 2 zeros, solutions, right? X-intercepts, something like that, roots. Okay, so let's go ahead and take a look at 2. If you have, for number 2, you had a discriminant of -5. So again, just making this up. What if you had like 1 plus or minus the square root of -5 all over 4? Notice square root of -5 is an imaginary number. And so, again, we're talking about real numbers here. You wouldn't have a real number x-intercept. You would have no x-intercept. So that's why you'd have A. The graph does not have a real zero. It does not have a solution when you set a function equal to 0. It would not have an x-intercept at all. What about number 3? I'm just making this up. What if you had like -2 plus or minus square root of 0 over 4? Notice when you say -2 plus 0 over 4, or -2 minus 0 over 4. That's the same number. So you're going to have, some people call it a double, I like to say a 0 with multiplicity 2. So you'd end up with something like B. And then again, I know that 16 is a perfect square, but again, it's a positive number, so you'd end up with 2 x-intercepts, just like we did for number 1. Okay, let's take a look now at numbers 5 and 6. 5, 6, 7, and 8, actually, you're going to solve for x. So what we're going to do is we're going to have 0 on one side of the equation. Then you're going to try and factor. And, you could use the zero product property, because remember, if you have like x minus a quantity, x minus a times the quantity x minus b equals 0, we know that x is a or x is b. Remember, that was the zero product property. Or if that doesn't work, you might have to use the quadratic formula. Okay, so go ahead and pause the video and try these 4 problems, see how far you get. Okay, so number 5 and number 6 I was able to factor. 7 and 8 I was not able to factor. But let's just take a look. Now, when you were doing number 5, again, the first thing you might want to try and do after you get 0 on one side of the equation. So we would think that, again, this first term you have to multiply to get 36x squared, and then the second term you'd have to multiply to get 1. And again, since the leading coefficient was not 1, it's not necessary, those two numbers are not going to add to 12. So again, we tried different things. 6 and 6 actually ended up working, but again, maybe you tried something else first. You might not have gotten on the first try. Just like over here, we're looking for numbers to multiply and give you 3x squared, and then again, numbers to multiply and give you -10, but you might not have gotten this on the first try. So now we know that x is -5/3 or 2. And over here, we know that x is -1/6. And some people call this a double root, or I like to say x equals -1/6 with multiplicity 2. Multiplicity 2 because, again, it was a double root. Okay. Let's go ahead and try number 7. Again, I tried to factor it and I could not, so I'm going to use the quadratic formula. So I also could not factor number 8. So I'd use the quadratic formula there also. So why don't you pause the video and set up the quadratic formula, and we'll just check that for 7 and 8 you know how to set up where to put the numbers. All right, so some common mistakes. Again, we know that we're squaring 2, and it's 4 for our b squared here. But notice our b was -6, but this number is squared. The b squared is supposedly positive. If b is negative, that b squared will still be positive. Also, count your negative signs. I have 2 negative signs, so it's going to be 4 plus 8. So that's why I have -2 plus or minus the square root of 12 all over 2. So I have -2 plus or minus 2 root 3 all over 2. And now you can factor a 2 out of numerator and denominator. And that's how I end up with -1 plus or minus root 3. And for number 8, again, I have 1 negative sign, so I'm going to do 36 minus 56, which is -20. So I'm going to have an I in my answer. So that is 2I root 5. And I can cancel out a 2. I can divide numerator and denominator by 2. There you go. Okay, so go ahead and take a look at the next page. We have some more solving problems. Some of these might look a little different, so let's practice a couple, and then I'll have you do some on your own. So notice if we do 9x squared plus 25 equals 0, try and factor. Now the problem is, if you try and do 3x and 3x and 5 and 5, so notice those are both perfect squares. If I do 2 plus sign, or two positive signs here, notice that the inside and the outside terms will cancel out, just like if I did 2 negative signs. They still will not cancel out to have no middle term. So I need a plus and a minus. The only problem is, how am I going to end up with positive 25? And that's why you need an I in there. So go ahead and double check. If you check your work, you end up with 9x squared minus 15ix and plus 15ix. So that middle term will cancel out. And then 5i times -5i is -25i squared. But since I squared we memorized is -1, that's plus. And that's how we know that you can factor it this way. So now 3x plus 5i equals 0, or 3x minus 5i equals 0. So we have 3x equals -5i or positive 5i, so x is plus or minus 5/3 I. All right, take a look at number 10. Now you could expand. You could multiply x minus 3 quantity squared times x minus 3 quantity squared, but that's a lot of work. So instead, I think what I might want to do is think of this as x minus 3 equals plus or minus 12. Because again, if you took the square root of both sides, right? Or think about it. If this is covered up, we can't see it. 12 squared is 144, but isn't -12 squared also 144? Okay, so that's how we did that one. So now, so now you could say that x minus 3 equals 12, or x minus 3 equals -12. Okay, why don't you go ahead and try number 11. Pause the video and try number 11. All right, so taking a look at this one, that means that 1 minus x equals, oh, that's very interesting. If it's -1, when I take the square root, that's plus or minus the square root of -1. So 1 minus x equals plus or minus I. So you could say 1 minus x equals I, or 1 minus x equals the opposite of I. Because again, if I squared is -1, we memorized that. We also know that the square root of -1 is I. So these are two things that we memorized. Okay. So going back to this one, We know that negative x is I minus 1, so x is 1 minus I. And over here, negative x is negative I minus 1, so x is I plus 1. All right, let's try number 13. Notice that you can, after you get 0 on one side, you can factor out a common term of x. So go ahead and pause the video and write down your two answers. So did you end up with 0 or negative 7/3? Okay, I think number 14 is actually kind of a trick. Notice that if you have the zero product property says that if you have x minus a times x minus b equals 0, we know that x equals a or x equals b, but notice this is a 5. Okay, there are a lot of things that you can multiply together to get 5. So we're going to have to expand. Now we want 0 on one side of the equation. And I tried to factor it, but I couldn't. So I'm going to use the quadratic formula. My a is 1, my b is 1, and my c is negative 11. All right, so go ahead and pause the video and see if you can find the final answer for number 14. So two minus signs, negative times negative is plus. So 1 plus 44 is root 45. And we can simplify that because 5 times 9 is 45. So the square root of 9 is 3. There you go. Okay, so here is our last one, number 16. Oh, actually we have two, 15 and 16. We're going to solve by graphing. So go ahead and type this into your graphing calculator. We will do 12x squared plus 7x minus 10. And then we'll put ny1 and ny2 we'll put 0. So for this one, notice if we graph it, you'll see that we probably, we actually I think could have factored this one, because notice this, I put a line in y2, y equals 0. So if I do calculate, intersect, which again you also could have done zeros of a function, but I think intersect is kind of quicker. Notice I hit enter, I'm on the first function, now enter it, move to the second function, guess. Notice there is at, let's see, 2/3. That would be 2/3. Let's do the other one. Intersect. Enter, enter. And again, I'm going to move over and try. I want to get the other 0 there, so I move to the left. And I hit enter. And that one's negative 1.25. So notice this is just another way to do it. So my answers are negative 5/4 and 2/3. But again, see how you could have factored that? Because 4x plus 5 equals 0. So again, subtract the 5. Divide by 4. Over here, same thing. But again, I could have graphed it. I'm sorry, I could have factored it, but I did graph it. Okay, take a look at number 16. What we're going to do for 16 is we're going to let x plus 1, how about let that be a, the grade we're all going to get on our next quiz. So couldn't you call that a squared minus 4a minus 12 equals 0? Go ahead and factor it with the a in there. So do you see how that was just easier to factor? So now we know that the zero product property that a is 6 or negative 2. But what was a? A was x plus 1. So now we know that x equals 5 or x equals negative 3. Okay, so that was just a different way to do that one where, again, we substituted everywhere we saw an x plus 1, we replaced it with a. Nice job, everybody.